All right, welcome. So today we're going to be going through the 2017 paper, and it's very easy. Again, it have 5 questions. Well, let me say 4 sections. I have 8 questions. You have to do everything from 1 to 6. And then in section 4, you choose either you do the statistics or you do the kinematics question. Okay, let's go ahead and start. Again, this is the formula sheet, so anytime you forget in a formula, you can always come back here and utilize this formula to like find the mean, probability, motion in a straight line, differentiation, some trig identities that you need to know. Just always come back here. So let's continue. Question 1, section 1. Functions question. It says f of x is equal to 2x plus p over x minus 1, where x is not equal to 1 and p is a constant. And it says for us now to determine the inverse of f. To find the inverse of f of x, first thing we're going to do is interchange x and y. So we're going to say x is equal to 2y plus p over y minus 1. Then what we're required to do is make back y the subject. To make back y the subject, we can just multiply across y minus 1 across here to get xy minus x is equal to 2y plus p. Now when you get to this stage, now you need to make y the subject. We can bring y on one side. So maybe you want to bring the y over here. So you'll have xy, and we bring over the 2y over here to become minus 2y. And that's going to be equal to, we can bring over the x over here. So the minus x over here, so become positive x. So we get x plus p. We can then factor out y. And factoring out y, we're left back with x minus 2. And that's equal to x plus p. So we're almost finished now. All you have to do next is just divide both sides by x minus 2. When you divide both sides by x minus 2, then you get y. And you're finished, voila. So this will cancel this. And so what we end up getting now is, so let's write it up here. So continuing up here, just finishing, we can say that f inverse of x, which is y, it works out to be equal to x plus p over x minus 2. That is f inverse of x. That's 2 marks. After you get that now, nice. So we have f inverse of x. It says now if f inverse of 8 is equal to 5, find the value of p. So they said that f inverse of 8 is equal to 5 to find the value of p. We already have f inverse right here. So f inverse of 8 is going to be 8 plus p over 8 minus 2. All we do is substitute 8 in for x right here for f inverse, and it says it's equal to 5. All right, so if 8 plus p is equal to 8 plus p over 8 minus 2 equal 5, we can cross multiply. And so 8 plus p over 8 minus 2 is 6. And so what we're getting then is 8 plus p is equal to 5 times 6, which is 30. And then we make p the subject by subtracting 8 from both sides. And so p equal 22. P is 22. All right, check it. 8 plus 22 is 30 over 8 minus 2. 30 over 6 is 5. So p is 22. That's one way you could have done it. An alternate way you could have done it was you could have set f of 5 equal to 8. All right, that's an alternate way you could have done it. Set f of 5 equal to 8. Well, let's continue. It says that given that the remainder when f of x is equal to x cubed minus x squared minus ax plus b is divided by x plus 1, the remainder is 6, and that x minus 2 is a factor, determine the values of a and b. So now, in this question, when it is divided by x plus 1, the remainder is 6. So that statement, by remainder theorem, it's telling us that f of negative 1 is equal to 6. That's all they're saying. So we can substitute x equal negative 1 into the function and set it equal to 6. So negative 1 cubed is minus 1, minus negative 1 squared is minus 1. Then negative 1 times a is positive a. So we get plus a plus b, and this is 6. So you could go ahead now and minus 1, that's minus 2. Bring over the minus 2, and you could just say a plus b is equal to 8. You could go ahead and do that. And then over here now it says that x minus 2 is a factor. If x minus 2 is a factor, then by factor theorem f of 2 is equal to 0. If f of 2 equal to 0, we can plug in 2 into the function, and 2 cubed is 8, minus 2 squared, which is minus 4, minus 2 times a plus b, and that is of course equal to 0. Now, so all we have now is a simultaneous equation to solve. So we can write it like this. We can say this is minus 2a plus b, and that's equal to negative 4. 8 minus 4 is 4. Bring it over the other side, it's minus 4. So that's what we have. Now, once you get to this stage, there are many ways you can do simultaneous equation, but in our estimation, I think the easiest way is to use elimination method. So we can subtract them. So we can say this equation 1, subtract this equation 2. I think this will be the easiest way. So a minus 2a is going to give us 3a. b minus b, that's 0. 8 minus 4, that is 8 minus 4 is 12. And so what we get is 3a is 12, and so a is equal to 4. Now once you get a is equal to 4, then we know that a plus b is 8, and so b must also equal to 4. So those are the two values. A is equal to 4, and b is also equal to 4. All right, so that takes care of this, and we continue. All right, now this part part C says the values of the variables p and x in table 1 is obtained from experiments that are thought to obey a particular law. It says p is equal to a times x to the minus k. And it gives us the values of x and p at some point in time. It says use logarithms to reduce the equation to linear form. Linear form, this is linear. Linear is always y equal to mx plus c. That is linear. All right, this is linear, y equal mx plus c. Always remember that is linear. So we take logs of both sides. So what we're going to get is the log of p is equal to, we take the log of this side, and we get the log of a x to the minus k. All right, so that's what we have, ax to the minus k. Now it says now, reduce it to linear form, so we need to break this out now, and we're going to break out that side, and that side is going to give us log a minus k log x. All right, and so here is where we put it in linear form now. Log p is equal to log a minus kx. It says using a suitable scale, plot the best fit line of equation ci on the graph paper provided on page 9. Use a space below to show your working. Here's the graph sheet, and we're going to plot it. So first thing is the biggest value for p is 121, and the log of 121 is 2. So we need an appropriate scale for the y-axis. So let's use a scale. Let's select our scale now. This is our y-axis, and our x-axis. That's our y-axis, that's our x-axis. And now, of course, we need to know we need to plot what is, this is what we're going to be plotting. Log p equal to log a minus k log x. All right. So pretty much the graph that we're plotting is log p versus log x. That's the graph that we're plotting. The graph that we're going to plot is log p versus log x. All right, we're going to plot log p versus log x. So on the y-axis is log p, and on the x-axis is log x. Let's try and deduce the scales that we're going to use now. Using a suitable scale, so you need to cover, what's the log of 10? We know that the log of 10 is 1, and so the x-axis, the biggest value is 1. So how can we separate this so that this goes out to 1? 0.1, 0.2, 0.3, 0.4. This won't work. So let's go 0.4, 0.6, 0.8, 1. That won't take up half of the graph. Let's go 0.25 then. 0.25, 0.25 here, 0.5 here. Yeah, this should work. 0.25 here, 0.5 here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is 0.75. I'm just trying to use up all the graph with my scale. 1, 2, 3, 4. Then this is 1. Nice and easy. So this is log x down here. Then we need now log p. To deduce log p, we look at the highest value in p, 121.5. And we said that the log of 121.5 was 2.1. So we need the highest y value to be 2.1. So maybe we can go, let me see. .2 or 0.4 going up 0.4, 0.8, 1.2, 1.6, 2.0. That would be too small. So maybe not so much 0.4, Let's go 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, 2.25. That should work. So this was 2, 0.25, 0.5, 0.75, 1. So this is the scale. All right. Each 2 centimeters represent 0.25 units. Okay, let's plot them now. All right, so the log of 1.58, that's the first one. 1.58. The log of 1.58 is 0.19 or 0.2. So let's go with 0.2. This is 0.25, so this is 0.2. So 0.2 maps to 2.1. This is 0.2 and it maps to 2.1. 2.1 will be, this is 2.25, so this is 2.125. So it is somewhere here. This is 2.1. That's the first point plotted. Let's use a different color. Let's use black. All right, we don't want to spend too much time here. Then 2.51 to 110. The log of 2.5 is 0.4. 0.4 is mapped to the log of 110.6 is 2.05. So 2.05 to 0.4. 0.4 will be 0.3, 0.35, let me see. 0.375, 0.4 is in between here. So we have 0.4 to 2.04. 2.04 is somewhere, these are just estimate. Oh, this point is not even plot correctly. This point wasn't plotted correctly. This is not 2.1. So caught up with getting it perfect that it's not so much accurate. Zero 0.125. So here 0.2 going up, 0.2, 2.1. 2.1 is here. Then we'll say the next point is 0.35. So 0.4 somewhere here, 0.4 to 2.04. Go with here. These are sketches. I'm not going to make it 100% accurate. Then log 3.98 to log 106. So the log of 3.98 is 0.6. So I'm just going to go 0.6, 0.81. All right. Then the log 106.2 is 2. So we're going to go 2 to 0.6. Zero 0.6 to 2. All right. Then we're gonna go 0.8 to 99.1. The log of 99.1 is 1.99. 0.8 to 0.0 0.875, 0.8 somewhere here. To 1.99. And then finally log 10 is 1 to log 93.8, which is 1.97 to 1. 1.97 to 1. All right, so my graph is way not accurate. It's not accurate at all. Draw a line of best fit. This is my line of best fit. Maybe yours is better. It should be better because this is not 100% accurate. That's my line of best fit. All right. And then using this, we're going to find out. Using this line of best fit, we're going to find out what is A and what is K. All right. So first thing we can just say, all right, C graph, because the graph is completed. Find out what is the constant A. First and foremost, log A is the y-axis intercept, and the y-axis intercept is 2.125. So what am I saying? I'm saying that the log of A is equal to 2.125, and so A is going to be equal to 10 to the 2.125 and so A is actually 133.4. That's what I'm getting for A, 133.4. If log A is equal to 2.125, then A is equal to 133.4, which makes sense. Fall in line with the values for P, don't it? Yep, because A should naturally occur when X is 0. Yep. All right, the next thing we need is the value for K. Now, to find the value for K, we need to know that minus K is the gradient. So minus K is the gradient, and so minus K is equal to y2 minus y1 over x2 minus x1. Looking at our line of best fit, we just need to use two y values that we have. So maybe we can use y2. So we can use 2.06 minus 2 2.06 minus 2 over x2 over x2 minus x1. x2 is y2 minus y1 over x2, which is 0.2 minus x1, 0.2 minus 0.675, 0.2 minus 0.675. All right, again, my scaling wasn't so accurate, so we're going to get that minus K is equal to, work out that, 2.06 minus 2 divided by 0.2 minus 0.675. I'm getting minus K is minus 0.126, and so in reality K is equal to 0.126. That is K. All right. Now this topic is known as linear reduction. This is linear reduction, one of the easiest topics in ADMA. Nice. Now we get to go to question 2. Question 2 says the quadratic equation 2x squared plus 6x plus 7 has roots alpha and beta. Calculate the value of 1 over alpha plus 1 over beta. So to find the value of 1 over alpha plus 1 over beta, here's what we do. One over alpha plus 1 over beta. First thing we need to do is find the LCM. The LCM between alpha and beta is going to be alpha beta. Clearly, alpha beta has to be the LCM. Alpha beta. Then alpha into alpha beta goes beta, and beta into alpha beta goes alpha. So we multiply them. And so what that works out to be is beta plus alpha. All right, so 1 over alpha plus 1 over beta is beta plus alpha over alpha beta. Now beta plus alpha, according to the quadratic equation, we know that alpha plus beta is minus b over a. We know that alpha plus beta is equal to minus 6 over 2. Minus 6 over 2 is minus 3, so that is alpha plus beta. We also know that alpha beta is c over a. We know alpha beta is c over a, and so alpha beta is 7 over 2. All right, nice and easy. So alpha plus beta, which is minus b over a, so that's negative 3. And that is also divided by alpha beta, which is 7 over 2. Feel free to use a calculator. Of course, many persons would just flip it and say, oh, that times that. Minus 3 divided by 7 over 2, that's minus 6 over 7. That's the value of 1 over alpha plus 1 over beta. Nice. Now, the next part of the question says, determine the range of values of x for which 2x plus 3 over x plus 1 is greater than or equal to 0. To find the range of values of x for which 2x plus 3 over x plus 1 is greater than or equal to 0, to do this, we multiply through by the square of the denominator. By multiplying through by the square of the denominator, we're going to get 2x plus 3 times x plus 1 is greater than or equal to 0. This is what we're going to get. 2x plus 3 times x plus 1 is greater than or equal to 0. Once we get to this stage, we're nice. You can just sketch a quadratic to see what is happening. The roots would be minus 1 and minus 1.5. This is minus 1, and this looks like minus 3 over 2. And they want the portion of the graph that is greater than or equal to 0. The portion of the graph that is greater than or equal to 0 is here, this region. And so what's the solution? The solution then is x is going to be less than or equal to minus 3 over 2, or x can be greater than or equal to negative 1. That's the solution. Nice and easy. Soft. That takes care of this. That's the range of values for x. So if you want to give them it in the form of a set, maybe you could tell them that x, the values that satisfies x is such that you put it in set notation. It really doesn't matter. All right, you can put it in set notation if you want. All right, nice. All right, now let's look at part C. Part C says an accountant is offered a 5-year contract with an annual increase And the accountant earned salary of $53,982 and $60,598 in the third and fifth year respectively. If the increase follows a geometric series, calculate the amount that is paid in his first year. So to calculate the amount that is paid in his first year, let's go ahead and do that. To calculate the amount that he is paid in his first year, we go right here. The amount he is paid in his first year, well, we know how much he's paid in his third year, all right? And for any geometric progression, the first term we know is A, the second term we know is AR, the third term we know is AR squared. All right, the fourth term is AR cubed, and the fifth term is AR to the fourth. What does that mean? That means that the third term, which is AR squared, is equal to that 53,982.8. All right, that is AR squared. We also know what is paid in the fifth year, which is AR to the 4. So if we divide AR squared by AR to the 4, look what we're going to get. AR to the 4. AR squared divided by AR to the 4, which is 53,000 divided by 60,598.89. When you do the division, look what you're going to get. The A is going to cancel the A. R squared over R to the 4 is 1 over R squared. And so we get 1 over R squared is equal to, do the math, 53,982.8 divided by 60,598.89. When you do the division, you get 1 over R squared is 0.89. Let me write that better. We get 1 over R squared is 0.891. And so all we need to do is make R the subject. If 1 over R squared is 0.89, then we know that R squared is going to be 1 over 0.89. And so R squared works out to be 1 over 0.891. So R squared is 1.122, and then we square root both sides to get what is R. So when we square root both sides to get what is R, we're going to get that R is the square root of that, which is 1.06. So that is the common ratio, 1.06. Now, since the common ratio is 1.06, remember we said that AR squared is 53,982.8. So what does that mean? That means that A multiplied by 1.122, we know that these two, when we multiply them together, is equal to 53,000. This is equal to 53,982.8. So all we need to do is make A the subject now. So divide both sides by 1.112 to get that A will be 53,982.8 divided by 1.122. And so A is equal to, do the division, 53,982.8 divided by 1.122. When we do the division, we get that A is $48,113.01. So that is what is paid. All right, so that is the amount paid in the first year. So give them a sentence. That is the accountant. I'm only assuming it's a man. He is paid $48,113.01 in his first year. That is what he is paid in his first year. Now the next part says find the total salary that he earned at the end of his contract. Now there's two ways to do this. You can add up all of these and you'll find out how many money he made. All right. The total salary is equal to the total amount of money made over the 5 years. So the total salary is equal to the sum of his pay in 5 years. The sum of pay that he made in 5 years is equal to his first year's pay of $48,113.01 plus his second year's pay, which would have been $48,113.01 multiplied by R, and R is 1.06, plus his third year's pay, which would have been $48,113.01 multiplied by R squared, which is 1.122, plus, made a mistake in here, 48,130 plus his fourth year pay, which is 48,113.01 multiplied by R cube, and R cube is 1.06 raised to the third power, plus the amount of money he received in the fifth year, which is 48,113.01 multiplied by 1.06 raised to the fourth power. That is going to be the total salary he earned. So you can add those up, 48,113.01 plus 48,113.01 times 1.06 plus 48,113 times 1.122 plus 48,113.01 times 1.06 raised to the third power plus 48,113 times 1.06 raised to the fourth power. So I'm getting that in total he made 271,140.61 That's his total salary at the end of his contract. That's one way to do it. Another way to do it, I'm just going to throw in an OR because I know people like the OR. You could have just used the formula that says the sum S5 is equal to, which means the sum of the 5 years, it's AR, so it's A, which is 48,113.01 A times 1 minus R to the n, which is 1 minus R to the n, 1 minus 1.06 raised to the fifth power over 1 minus R over 1 minus R, which is 1.06. So you could have used this formula as well and work it out. Let's work that out. So 1 minus 1.06 raised to the fifth power times 48,113.01 divided by 1 minus 1.06 And I got something slightly different here. I got 271,217. That's when I did it this method. Of course, I think they'll give you the full marks either way. All right. Either way is fine. Nice and easy. Soft. That takes care of question number 2. Question 2, jolting, soft. Question